Welcome back to Beyond the Numbers. Hi, I'm Homolola Astrop. This is episode 3 of our SQL to Dashboard series, and today we are tackling the concept that unlocks the real power of SQL, the joins. We are covering the inner join, the left join, and how to link the tables together. So today you learn how to combine two or more tables to answer questions that a single table simply cannot answer. But to get a good grasp of what we're doing today, you need to see the last episode titled Your First SQL Query Using Real-World Data. Kindly go back to it and follow the steps therein. For today's tutorial, we have added another file to the GitHub folder that we referenced last week. The file name is SQL JOINs, combining tables to answer real questions. So kindly go back to the folder, the GitHub folder. You have the link below. Open it and open your DB mentorship_DB and follow along as we go. Let's do a quick recap of what we did in the last episode. We learned how to use select and from to choose columns and a table. We learned how to use where and and to filter rows with precision. And we learned how to use count and group by for aggregation. Those queries were powerful, but they all had one limitation. They could only look at one table at a time. Now look at these three questions that you have on the screen. You have which customers generated the most transactions in 2023. Then we also have which branches have the most active customers. Then lastly, we have which customers have never made a transaction. Every single one of those questions requires data from two different tables. Customer names live in the customer table. Transaction amounts live in the transactions table. Then branch names live in the branches table. So you cannot answer any of these questions with one table. That is the problem joins solve. They connect tables together using a shared column, and suddenly the whole database becomes one connected system. Now, moving on, why is one table never enough? Look at what we have here. On the left, the customers table, it knows who our customers are. It knows the names, the state, account type, dates joined, but it has no idea what they have done with their accounts. On the other hand, on the right side, you have the transactions table. It knows what happened. Every deposit, every withdrawal, every transfer with the amount and the date, but it does not know the customer's name. It only knows the customer ID. So if I ask, how much did Chukwuemeka Obi deposit in 2023? The customers table cannot answer it. The transactions table cannot answer it. But if we connect the two tables using the customer ID that appears in both tables, then they can. This is what join label in the middle of the diagram represents. Customer ID is just the bridge. It connects the two tables. When you join on customer ID, SQL matches each customer row to all their corresponding transaction rows. The result is a combined table with names, states, and transaction values. There are 4 join types. We are starting with the most common ones, the inner join. So let's start with the inner join. I want you to look at this diagram. We have 2 circles, customers on the left, then transactions on the right. The overlap in the middle is what the inner join returns. So inner join only gives you rows where a matching customer ID exists in both tables. Customers with no transactions are not included. Transactions with no matching customer not included. Only the overlap, only confirmed matches. So when are you expected to use this? When you want customers who actually made transactions. For example, Show me all customers and their total transactions or their total spending in 2023. If a customer never spent anything, you probably won't see, you don't want to see them in the results. So in this case, inner join is the right tool. Think of it as a strict handshake. Both sides have to show up. If either side is missing, then the row is excluded. Now let's go to the left join. This gets more interesting. So I want you to look at the Venn diagram. The entire left circle, all of customers, is highlighted, and the right circle, transactions, we have it there. It's a bit faded. Now, left join returns every row from the left table, regardless of whether a match exists. If a customer has transactions, those transactions details come through. If a customer has no transactions, they still appear in the result. But the transaction columns will be null. What do I mean? Empty. There will be no value there. So null in SQL's way of saying there's no matching row on the right side. And that null is actually the most useful thing in the result because null tells you exactly which customers have never transacted. So when would you use left join? You will use left join when you want all customers, including dormant ones. When you want to find absence of data, not just its presence. So here's the pattern. Left join, then filter where the right table column is null. We'll see this in query 2 shortly. So this is the most important slide in this episode, and I want you to pay attention. This rule breaks almost every one where we have the where versus on. And I want you to look at these two code blocks side by side. On the left way, which is the wrong way, the query has a left join, but then it puts a filter on the transactions table in the where clause, where t.txn underscore type equals deposits. That sounds reasonable, but here is what actually happens. The join runs first and returns all customers, including those with null in the transaction columns. Then where runs and where t.txn underscore type equals deposit eliminates every row where txn underscore type is null, which means every customer with no deposits gone. Your left join has silently become an inner join, and you will never know why your results look wrong. Now let's look at the right, which is the correct way. The filter goes inside the on clause, and t.txn underscore type equals deposit. Right there alongside the join condition. This means the filter runs during the join, not after it. Customers with no deposit still appear. Their transaction columns are null. The left join is preserved. So here is the rule, and I want you to write this down. Filter conditions on the right table go in the on clause, not where dot on. If you put them in where, you lose your left join silently and with no error message. You just realize that your results are wrong. Now let's apply all what we have talked about. And let's look at this business question. Which customers generated the most transaction value in 2023? And where are they? So look at the query. We select the customer's name, the state, and account type from customer table. We also count the number of transactions and sum the total amount from customers aliased as C. Inner join transactions aliased as T on customer underscore ID. And we filter inside the on clause for the new year 2023. Group by the customer's column, order by total value descending, limit 5. The alias C for customers and the T for transactions are important. Both tables have a column called customer ID. If you just write customer underscore ID in the query, SQL does not know which table you mean. So that's why C.customer underscore ID means the one from customers table. T.customer underscore ID means the one from the transactions table. Always alias your tables when you're joining. Now look at the results. We have Okoyemi Olawale in Lagos, 14 transactions, 46.2 million naira. Danjuma Lawal in Abuja, 15 transactions for 3.8 million. The so what question that comes to your mind is the bank's highest value relationships are concentrated in 2 cities. Any VIP program, relationship manager assignment, or premium product launch should start in Lagos and Abuja because before expanding to the other locations. So do not spread resources evenly. Follow the rule. Now you can see that you are thinking as a data analyst. You can advise your stakeholders based on the analysis you have done. Moving forward, we want to look at another business question. Which customers have never made a transaction? And should we be concerned? This is a left join question because we want all customers, even those with nothing on their right side. Now look at the query. Select the customer's name, state, account type, and date joined. We also select t.txn underscore ID with a comment explaining it will be a null if no transaction exists. From customers, left join transactions on customer underscore ID where t.txn underscore ID is null, is empty. The last line is the key. The left join returns all customers. Those with transactions get a txn underscore ID. Those with no transactions get null in the txn.id column. Where the t.txn underscore ID is null, then keeps only the customers where no match was found. The result is a list of dormant accounts. Notice that where filter is on txn underscore ID, which is the primary key for the transactions table, it is not a filter on a value column like txn underscore type. Filtering on is null to find missing records is safe in where. It is the value filters like txn underscore type equals deposits that belong in HON. Now the so what. Every dormant account represents a cost already paid, acquisition and onboarding. So for an organization, you have spent on acquisition, you have scored on onboarding, and the account is still dormant. So you have no return. So the list is the retention team starting point. Your company's retention team, that is the list is what they need. They need to target reactivation offer sent within maybe 30 days, and you recommend the action that they are going to take towards it. Then moving on, 3 queries. We want to look at having 3 tables in one query. An example of business question you can have is which region generated the highest deposit value in 2023 and how many customers drove it? To answer this particular question, we need 3 tables: the transactions tables for the deposit amounts, the customers table for customer count, and we have the branches for the region. Look at the query structure. From transactions, that is our starting table because it has both the customer ID and the branch ID. Join customers on customer ID. This brings in customer information. Then you join branches on branch ID. This brings in the region. So 3 tables, 2 joins, and the pattern is the same. Each join needs a shared column. Transactions and customers share customer ID, transactions and branches share branch ID. So we filter for deposits only, and for the year 2023, then group by region. If you look at the results, Southwest has 12 customers, 61 deposits, and 155 million naira. The North has 8 customers, 40 deposits, and 113 million naira. Then you have the South South and Southeast together contributing less than 20 million naira. Then so what comes again? Southwest drives 54% of total deposit value. Southeast and South-South are active regions with real branches, but are significantly underperforming relative to their potential. So these are not struggling markets, they are untapped ones. And they need dedicated growth strategies, not just marketing. So you can say that as we go further as a data analyst, you are able to advise your stakeholders on what to do. And that is exactly your role based on the data that you have. Now it's your turn. I've done a lot of explanation, and the practice query on screen has 3 deliberate gaps for you to fill. The task: find all savings customers who joined after 2020 and show their total transaction value in 2023. Make sure you include customers who made 0 transactions. Now, 3 questions for you to answer before you look at the GitHub solution. 1. Which join type do you use and why? What happens to your result if you choose the wrong one? Then 2. Where does 2023 date filter go? Inside on or inside where? What is the difference in terms of what the query returns? Then the third question is, after you return it, write your so what. What does this result tell the bank or your organization about its savings customer base? The answers are in the SQL joins file on the GitHub, but try it yourself first. That is where the concept is going to stick to you, to your memory. And I want you to post your so what in the comments. I'll read everyone. Then we're rounding up. So your joins quick reference. I want you to note this particular slide. You can screenshot it and just keep it handy. Everything we have covered today is in this table. The inner join, matching only rows from both tables, use when you want confirmed matches only. The left join, all rows from the left, null where no match on the right. Then use when you want everything from the left, including records with no match. Then you have the right join, all rows from the right, null where no match on the left, and it's less common anyway. Most situations that need right join can be rewritten as a left join by swapping the other table. Then multiple joins, where you chain as many tables as you need, one join at a time. And the golden rule, one more time: filters on the right table go in on the on clause. Putting them in where silently converts your left join into an inner join. No error message is not going to give you any warning. You just realize you're having wrong results. You can always come back to this anytime, and until it becomes automatic for you. So in our next episode, we are going to talk about group by, having, and the window functions, rankings, running totals, month over month comparisons, the patterns that move you from the intermediate to the advanced SQL. So that is all for today's episode. And you now understand how to connect your tables. You now understand how to use your inner and the left join. And you know when to use the where and when to use the on rule. Your homework: run the queries and the practice query from the GitHub file. Write your so what for each one. Put them in the comment section. And in the next episode, like I said, we'll go to the group by and having and the Windows functions. If this has really impacted any knowledge on you, kindly subscribe, and so that you will not miss the next episode. And please share it as much as you can. I am Omolola Astrop, and this is Beyond the Numbers. Bye. See you next time.